But what I want to talk about today is the additive manufacturing within Creo 4.0 and some of the advantages that we've made just through the past year, actually. And so how I want to structure this is take you through the journey of the traditional methods of additive manufacturing and some of the hiccups there, and then I'll show you what our vision is. And then as I step through our vision, I'll actually jump into Creo 4.0, and I'll show you how to do that in real time. And I'll wrap it all back up into a value, and then we'll move on from there. So let's actually just jump right into it. So like I said, today we're going to be talking about Creo 4.0 and additive manufacturing within it. And the traditional way many companies go about doing additive manufacturing is they procure some type of model. If it's in Creo or some other software, they create their 3D model. Maybe they run some optimizations, and that could be either within their software or maybe they have to go to third-party softwares. So then they have their optimized design, and then they go ahead and print it. So what they do is they, make a general idea of what the model is going to look like, and then they physically print this thing out. And then they take a look at it and say, hey, was this a worthwhile print? Do we have thin walls here? Did this break under construction? Is this going to hold the structural integrity that we need to? And then once they, analyze this physical product, they then go back into it and do they re-optimize the shape, they go back into the CAD, they rebuild the geometry, and this could be an endless process until they get the design that they need. Where our vision is to have a one-stop shop within PTC Creo. And the way we do this is, since Creo is an associative suite of applications, you can design within Creo 4.0, do all of your optimizations, validate it, so check for things like thin walls and things like that. Do a 3D print check before you even print it out. So if there's any overlap or if the support materials are going to cooperate, things like that, you can check that right before you even print it, so you know when you print it, you're getting the product that you need and you can trust that it is within the parameters that you need. So let's talk a little bit about the capabilities. Now, Kyle said, PTC is partnering with Stratus and 3D Systems. That's a couple of the 3D printing companies that we're partnering with right now. That list is going to be determined to expand some, and our goal is to streamline 3D printing workflows of PTC Creo and supported 3D printers. So let's actually take a look at the process here. So traditionally what you could do with Creo 4.0 is you create your part, and then since we are partnered with Stratus, you can automatically print that out. Or if it is with a company that we are not currently partnered with, you would just tessellate the model into an STL file, have some intermediate software interpret that STL file to translate it into some type of G-code, and then you would send that all over to your user-defined 3D printer. So we are looking to support additional printers in the future, so look out if you have some printers that are not listed here. Certainly in the future they may become part of that list. So one of the huge things that we did in terms of additive manufacturing is incorporate a lattice structure. Now this lattice structure is really cool because not only does it cut down on the amount of material and the cost of your part, but it allows you to create parts that still hold the structural integrity that you need. And so we can actually take a look at this. The traditional thing here, maybe we have a model of some type of grabber. If we were to print this out now, it would be right under 5 pounds. But applying a lattice structure to this, you can actually see we cut it down significantly to 3.8 pounds, thus saving us time, material cost, and material in general. So one of the ways that we prove that this works is we couple the lattice structure with Creo Simulate. So you don't have to just take my word for it. You can actually go into the software, run a simulation analysis on this, do a static structural, or we do within Simulate, and then you can actually have Simulate create an optimized model based on the design parameters that you set in place. So just by putting the lattice structure in, remember we were at 3.8, we optimized the model, and we cut it down by 0.2 pounds just from that, and we know that's the best model possible. So this is all talk right now, this is all great through the PowerPoint slides, but let's actually take a look at the software so I can prove it to you. So here I'm within Creo 4.0, and what I'm looking at is the same model that I just showed you in the PowerPoint. And just for fun, let's take a look at the mass properties of this guy. So if we were to preview this, you would see our mass is about 0.2 pounds, not too bad, but let's see if we can get a bit better. And let's do that by utilizing that lattice structure that I was talking about. So to do that, let's just do some slight modifications here. Maybe I blow out the center here. And now we're going to inject this with a lattice. So you can see, looks pretty good, but we do have some things kind of floating within 3D space here. And it looks like I lost sound. Can you guys still hear me? Hello? Yes, we can hear you. Okay, just want to make sure. Okay, sounds good. Okay, so we're looking at this lattice structure, and it's looking pretty good, but we can actually make some refinements to that as well. So under this tab, under the cell tab, you notice we had some dangling beams. Well, we could take care of that. We can take care of the dangling beams. If we wanted to get rid of the angular beams, we can do that. And let's actually take a look at that as well. So it looks a little bit better. But the idea is here just to get the most optimized design here. So I was talking about the different lattice types. We have our 3D, we have our 2.5D, and along with that we have different options for that. So let's actually choose the quasi-radial, see what that looks like. And one of the really important things with 3D printing is when you 3D print, a majority of the time you're going to have support material. And a way to get rid of that support material is to submerge your finished product into a bath. And so you need to have a way of draining out that support material, especially if you have something like a lattice structure inside. So we actually have the ability to create drain holes in this as well, so you can actually add those into there. So we pretty much thought of all the different avenues for 3D printing within this lattice structure, so you know you're being well taken care of. So there's a lot of different functionality in there. I just kind of wanted to give you a taste of that. And let's actually just go back and choose our regular. I'll accept that, make sure that's the one we want. And then we'll move on and we'll actually prove that this is the most optimized design. So now we have this model here, and if we go into our Analyst tab and we take our mass properties again, check that out. We're at 0.6 or 16 pounds, which is roughly half of what we were at before, which is awesome. And like I said before, if we wanted to, we can actually optimize this through Simulate. And let me just give you a quick rundown with that. So whenever you're doing any type of simulation, there's three main things that you need to do. Number one, you need to add a material to your part. Number two, got to add your constraints. And number three, add the forces. And that's just standard with any finite element analysis that you want to do. So let's actually start that off. And so the first thing I'm going to do is add a material to this. And this is brand new to Creo 4, this library that I'm showing you here. So I have the standard materials Grotto design folder, and you can see there's some preset materials setting in here. So let's just grab a plastic, and we'll assign that to our material, or to our part. We'll launch Simulate. And then from here, we'll just do traditional FEA like we would normally. Let's wait for that to load. Okay, so traditionally what we would do is just add some displacement on here. Maybe we want to hold this firm. So let's just grab a couple of these guys here. And let's add a force to this gripper. So maybe I want to put it on the bottom side. And let's put some values in here. Okay, give it the correct units. And let's preview that. So that looks pretty good. Okay, so what we're going to do is test to make sure that our lattice structure can actually withhold the analysis that we're putting on here, so we know that this will work when we print this out. So within Simulate, we have a number of different design studies that we can do. So I'm just going to do a standard static. And yeah, it looks like our constraints are in there, our load's in there, so we're all good. And we're going to run it. And so what's really cool about Simulate, just to kind of give you a really quick background, is it's actually going to generate a mesh on its own, so I don't have to worry about that. So it's basically going to do a nodal analysis on this, testing the forces and the constraints and how those interact with that, and it's going to refine the mesh and go until it converges on a certain point. And you can actually see that here. So we're doing a multitude of passes. Pass 1 is, checking the differential equation that runs this, and it's going through and calculating this based on what I set up here. So now it's complete pretty quickly, and let's actually open that up in a separate window so we can actually see that in action. So that's one of the another really cool things within Simulate is it actually shows you the results, things like the von Mises stress or the maximum displacement or the principal stress. So you get an idea of what's actually going on here, and you can see where the max stresses are before you go and actually manufacture this. And let's say for our case that this works out, and now we know for sure that this is a good lattice structure. It's going to hold up to what we need it to, and now we can go and actually print. So let's see how we do that. So we talked a little bit about, the new printing functionalities within this. So even within Creo 3.0, you could already prepare a 3D print, but we actually added some functionality to that. You can also order a 3D print. So any online vendors that you have, you can send that out to them right through here. So let's actually take a look at preparing this. And you can see right here, I can actually associate a printer. So since I'm using a Stratus printer here in Greensburg, PA, that's already set up for me, but I can actually, select on other printers that I had saved. And so we're going to keep that there. And you can see, here's my part. It's lattice structure, and it's just arbitrarily placed within the envelope here. Now, I can place this down however I want, or I can have the system do that. And then one of the really cool things, one of the really useful things that I use a lot, actually, is this printability validation. Now this is going to show you if we're going to have any thin walls or narrow gaps or anything like that. So all we have to do is choose the material and then select compute. And we'll put on some type of tolerance. We'll say a minimum wall thickness of 0.7 is what we want to go with. And right here it says, yes, there is a violation there. So now that I know that, I can go back and make the necessary changes before I even print. I can even check for global interferences. So if I did something like a pattern, actually do something like that. If I wanted to fill this whole thing up or do it by direction, let's do it by that. I could do that. And you can obviously see there's some overlap here, but if you had a more complex part, maybe it's not so glaringly obvious. So you can use this global interference to check if there's any overlap here, and clearly there is. So I can, again, move that by myself, or I could say, hey, system, go fix that for me. So pretty cool. And then at the end of the day, we can actually preview this, and we could check the support material that's going to be generated, and we can also check for clipping. So this is the actual additive manufacturing process. You can see the support material is being built up, and there's our actual gripper that we want to print out. And then from there, the final step, again, is to just save this as an STL file, and we would send this out to our printer, and then you can customize this however you want. And there we go. So that's basically what additive manufacturing is in a nutshell within Creo 4.